Next, we're going to be looking at the period of tangent and cotangent. Remember that period is the horizontal distance it takes for the graph to repeat itself. First of all, let's take a look at tangent. Tangent is a series of S-curves. As we can see here quickly on the graph, it actually only takes pi units for the pattern to repeat itself. Again, we can take this line and move it anywhere, and the distance between those 2 points, or any 2 points where the graph repeats itself, is going to be pi. Now, why is that? Well, let's take a look at the unit circle to verify this. Why does tangent have a period of pi and not 2 pi? Well, remember that tangent is y over x. So once we get to pi, look what happens. We get the same point as we did right here, except they're both negative. If they're both negative, then we're going to get the same tangent value back because you're going to get a positive back. Remember, all students take calculus, tangent's positive in the third quadrant. And then that kind of confirms again when we get to the fourth quadrant. It goes back to being the x is positive and the y is negative, which is reverse of this, but it won't matter because y over x will give you the same tangent value. And so that's why the tangent has a period of pi, because the tangent values repeat themselves after pi. And then once you get back to 2 pi, it starts over again. So every pi or 180 degrees, the tangent values repeat. All right, and this is the same for cotangent. I'm not going to go back and explain that one again. Tangent's just cotangent's x over y, so you'll see that the period is the same. Here's your proof for the period of tangent and what happens when you introduce a number b here in front of x. First of all, if you plug in 0, you're always going to get 0 back, since tangent of 0 is 0. And then since we want bx to be equal to pi this time and not 2 pi, in order to get 0 back, looking at this graph again just to confirm that, pi comma 0, we will set bx equal to pi and then solve. So we will divide both sides by b, and we get x equals pi over b. The period is the distance between your second x value of pi over b and your first of 0, and that would give you a period of absolute value of pi over b. It's going to be the period for tangent every time. Now here's a little proof like we did before, showing exactly what happens when you introduce like an a and a d. Your initial value will be this when you plug in 0. I'm not going to go over this whole proof because it's very, very similar to the sine proof we did when showing the period for sine. When you plug in pi over b, you get the same exact y value as when you plugged in 0. Therefore, this confirms that the pattern will repeat itself when it goes from 0 to pi over b. And for any function g of x equals a tangent bx plus c plus d, the period is just the distance between these two x values, and it ends up being absolute value of pi over b. So again, the period for tangent is absolute value of pi over b, not 2 pi over b, just absolute value of pi over b. How about cotangent? It works the same way. Cotangent looks different. I mean, it looks similar but different. It starts at an asymptote, and then it still just takes pi units for it to repeat itself and get back to that same asymptote. I'm not going to go into a whole lot, I'm not going to explain this as much as I did for tangent because it's exactly the same process. We start out as an undefined or an asymptote. We want to arrive at that undefined again, so we would set bx equal to pi, and voila, the period of cotangent is absolute value of pi over b. I'm going through this fast, but if you have any questions about this, please feel free to ask me. The proof is exactly the same for tangent as far as you getting the same y values if you introduce a c and a d. Exactly the same proof, actually. So, no matter what modifications, the period of cotangent is always going to be absolute value of pi over b. Now, without further ado, let's do some examples. What is the period of tangent of 2 pi x? Well, we can quickly see that b is 2 pi, so you still have to figure out b. But the formula now for tangent is absolute value of pi over b, not 2 pi over b. So it's going to be the absolute value. I'm going to plug in 2 pi for b, since that's what my b value is. Pi's are going to cancel. I'm going to get the absolute value of 1/2. So the period is 1/2 for tangent of 2 pi x. Let's look at the graph. Here is the original tangent. We're going to introduce 2 pi and see what happens to the period. And in fact, I'm probably going to zoom in a little bit so we can see what's going on. But yeah, we see that the graph repeats itself after 1/2. This is 1 and this is 2. It repeats after 1/2 and become a very cylinder graph. So that's a confirmation for our tangent example. Period of tangent of 2 pi x is 1/2. Next example is cotangent. We have 2 cotangent of negative x. This one's real easy, right? Since the coefficient is, well, it's not there, we can actually quickly introduce a -1 here, and that's going to be our b value. So therefore, the period, again for cotangent, is absolute value pi over b, same for cotangent. So plug in -1 for b. Pi over -1 is -1, but we take the absolute value, so guess what? The period for this is just positive pi. Okay, in the gray we have the original cotangent function. We can see its period is pi. The new function, the 2 cotangent of negative x, we can see in the black. And we can quickly see that the period remains pi. I didn't think about that until I looked at the graph. The period is still pi. It still takes pi units to get from one to the next. In fact, you could look at the asymptote and tell that too. It's just that it flips the graph. Pretty interesting. So sometimes the period will stay the same even if you introduce the -1 here for cotangent. The period will still be pi. Pretty interesting. That's it for the periods of cotangent and tangent. If you have any other questions about this, let me know.